Hello guys, welcome back to my new video. So, what's the question of today? What's today's question is wood cutting made easy. So, this problem you can find from the topic of searching and sorting in a hard type. If the level of the question is hard, that you can find from the Coder Army sheet. Okay. So the question is wood cutting made easy. Now let's read the problem. So let me directly give you what we have to do here. So we have one array which is given. Let's say I'll just tell you what's the thing that we actually have to focus. Now this is the length of the trees. This is the length of the tree, means the elements of the array define the length of the tree. Okay, now what's this B? B is the remaining product, means let's say we have a tree with length 20. Now we have another tree with length 50, we have another tree with length 10, and we have a one tree with length 17. Now let's say we are cutting the tree in such a way that let's say we are cutting to the height 15, means here we are first cutting, we are 15, so we are cutting the 5 from the upper. Okay, here it's the 15, so we are not cutting anything. Here it's 10, so we are not cutting anything. Here it's a 17, so to make it 15, what we are doing, we are just cutting the part which is extra, which is a 2. So now add this extra part. So 5 plus 2, here 0, 0, 2. So 5 plus 2, which is 7. That is given. And we have to find this value. Means the maximum value of the cut. Means what's the maximum value or the maximum height of the tree so that we can get a B equal to 7. Okay. So that's the question. Or here, if you are going for the multiple test cases check, then you can also take the not exactly value 7, but the nearer value to the 7. Okay, the value should be nearer to it. Because for some of that cases, it is not working for exact value. So that you have to keep in the mind. And if you have any problem understanding, then this is the question. Means the understanding is very simple. Like if you have given the length and the cut means 15, means what should be the maximum height of all the tree. If the height of the tree is greater than this value, then you just have to cut it and make it 15. Because for the first question, it's given, let's say it's given 15. So we have to reduce here a 5 and here a 2. Now, if you don't get it still, so let's check for the second example. In second example, we have array which contain 4, 42, 40, 26, and 46. Now, let's say we have given a 36, means all trees should cut till 36. If the value of any element greater than 36, then we have to reduce it till 36. So it's a 4. So we don't have to do any change. So we are not removing anything. Now it's 42. So what we are doing? We are cutting the 6. So now it's become 36 and we are cutting 6. Now for 40, make it 36 and we are cutting of 4. Yeah. 26 is less than 30, so we are not cutting anything. 46 is greater than 36, so we are cutting 10. And after cutting the 10 from 46, it will become 36. Okay. So what's the sum? Sum is 20. So now this 20 is given to us, and we have to find this value, 36, means maximum height. Okay. So I think you got the problem. Now, how to solve this? So for solving the problem, what we have to do? Let's say first we are sorting, or if you don't want to sort it, then also first So what we are checking from, let's say, minimum value to up to, so this is the output that we are getting, okay, after the cutting, but we don't want it. We want the value. So we want the value of the height that we, so that after reducing to that height for all the elements, we are getting a B is for the first 7, for the second 20. Okay. So, what I told you. Okay. So, yeah, what we are doing. So we have to search for each value. Wow, what's that mean? Like for check for the 4. Now check for 4 and reducing means here we have, for practice I told you we have, let's say, given height 15 and check for 15 whether we can find a 7 or not. Like that we have to check for each element. Each element means for here, let's say, check for 4 whether we are getting b equal to 7, then check for 5, check for 6, check for 7, up to the maximum element, up to the 46. So what we have to do? Let's say we are taking a 4, then check the height is for greater than 4. No, so we are adding 0. Now doing 42 minus 4 means 38 and make it to the 4. Like that we have to check for all the element, and we know that this is in the sorted order. So for linear search, also you can do like check for the 4, then 5, then 6, then 7, up to 46 and 4. Each this value you have to check whether you are getting output B is the same, and if you are not, then go for the next value. Okay, like that you can do it, but it's basically a linear search. So if we have a linear search and this is the sorted order, so then we can also do a binary search. How we can do a binary search? This is the sorted range in which for the all the elements we have to check. So uh, by checking each element, we can do binary search. Like first check for the mid. If it satisfy mid, then just edit. Then go for the left and the go for the right. Based on that, we have to put the condition. Okay. So now let me tell you how we can do it. So let me directly explain you the code. So this is the code. Here we are for sorting, then for taking first is minimum and the last is maximum. So if you want to implement directly here, then what can we say? So first, let's sort the above array. So what we are getting 4, 26, 40, 42, and 46. Okay. So we have minimum is 4 and maximum is 46. From we are getting answer in this range only. Now we are finding the mid. Our mid is 25. Mid value is 25. So we have to check for the 25. What we have to check for the 25? The same thing. How we can check it? So for 25 is I'll implement is sufficient function. What is sufficient function is doing is sufficient function. So traversing the array in which if the value is greater than 25, de then just remove and make it till 25 and the remaining part add it to the sum because we have to check for the B. So here, let me tell you one thing. So as I told you, what we are doing, we are first checking for 15. So check if the 25 is our actual answer or not. So what we have to do, we are taking the one length sum and in which we are storing the summation. And what's the summation? If the value or the height of the tree or the value of the element of the array is greater than 25, then just make it to the 25 and the extra added to here. So for we don't have to add anything. For 25 we have to add one. For 40 we have to add 15 For 42, we have to add 17, and for 46, we have to add 21. Now check this value is equal to 7. I think it's not equal to 7. Okay, let's watch here. We are checking the summation is greater than or equal to 7 mean length. Okay, so we checked here. Here we are applying B, so it's greater than or equal to 7. So no, it's not true. Then we are taking our mean to 26 because we know that with this value we are getting more sum, but we want to less it, make it less. So we are just moving to the right side. Okay, so we are taking our mean to the mean plus 1. And for the else part, we are just taking max to the right side because if we are getting more or less sum than this, then we have to move to the right side. Yeah, that's the whole logic of this code. As you can see here, this is very simple code. And after that, what we have to return here, we have to return here this value, right? So that's what we are returning here. The height, which can be the maximum of the sufficient height, and mid means from both of this value, which is the maximum that we are returning. It is a very easy example. I think you like this example. Okay, so if you like this video, then do like and do share with your friends. Thank you guys.